Welcome back to my channel, Mr. J Maths&Logics channel, where we make mathematics easy for everyone. Today we are going to look at trigonometry involving 2D shapes and also involving variables. We don't need numbers. At this point, in this section, what we test mostly is understanding, basic understanding of everything that has to do with trigonometry, especially when it comes to solution of triangles. So let's look at this. They say from the given diagram, show that BC is equals to k sine 2 alpha over sine of alpha. Now we ask ourselves, how can we get sine and sine in the denominator and in the numerator? We know that we can only have double sine if we are using sine rule. Only if we are using sine rule. But first things first, we fill out our triangle. K was given here, and this is an isosceles triangle. So, angle opposite equivalent will always be equal. Base angles of an isosceles triangle. So we use this also, and we use the approach of sum of interior angles of a triangle being 180 to get the equivalent angle. So let's go. So we have x will be 180 minus alpha, and our reason is sum of angles in a triangle. Now that we have this, we simplify. So our angle x will be 180 minus 2 alpha. So this angle will be 180 minus 2 alpha. Now we use it and use sine rule to get this. They want yz in this case. So yz in this case using sine rule will be yz over the angle facing it. That was why we went through this stress, because we need to get the angle facing that length. Yz over sine of 180 minus 2 alpha, and then we have equals to, you choose another side, we have k over sine of alpha. What do we do here? We cross multiply. Cross multiplying gives us 1z sine alpha is equals to k. Sine 180 minus 2 alpha, this is broken down using reduction formula. It falls on the second quadrant, and sine is positive on the second quadrant. You see the combination of triangles and reduction formula, trig is trig, anything can pop up. So 180 minus 2 alpha is sine of 2 alpha. So now yz will then be, if we divide both sides with its coefficients, yz will be k sine 2 alpha over sine of alpha, which is what they want us to arrive at. Now let's look at the second question. The second question is asking us to get yz squared is equals to 2k squared plus, we should prove this. Remember, there's no mark allocation for this, so it must be done properly. So what do we do next? We check what of the solution of triangles will work here, area rule, sine rule, or cosine rule. Looking at this, we have squares, so cosine rule will work because cosine rule is the only one that has squares. So remember, for cosine rule, for us to use cosine rule, we need two sides and included angle. We have an included angle and we have two sides. K is here. Because it's an isosceles triangle, k will be here and k will be here. So we go on. Now this is going to be yz squared is equals to k squared plus k squared minus 2 times k cos of the included angle 180 minus 2 alpha. Now going forward, we have our yz squared as 2k squared minus 2k squared. If we simplify, cos of 180 minus 2 alpha is also on the second quadrant, but cos is negative. So we have negative cos 2 alpha. Simplifying further, we have 2k squared Minus minus is plus 2k squared cos 2 alpha. Always check what was given to make sure that you have arrived at the destination. Now we've not gotten here. What do we do next? We keep on simplifying. We factorize and we have 1 plus cos of 2 alpha. And that is what? Please note there's no mark allocation for this. So you must get all your marks in the simplification. Everything needed must be taken into consideration. The idea that this is isosceles triangle and everything must be taken into consideration. And then check your expression, continue simplifying until you get to your expression. I'll see you in the next video. Please keep on sharing and encourage your friends to subscribe.